Hello year 8s and welcome back to mathematics. In today's lesson we're continuing with our topic of measurement and we're continuing with what we looked at last lesson with Pythagoras' theorem. So over in the next couple of lessons, as I said, we're going to be looking at Pythagoras' theorem, this theorem that helps us relate the three sides of any right angled triangle. And so in today's lesson, what we're going to be doing is we're going to be using Pythagoras' theorem to help us find the lengths of missing sides. So if you have a look at today's learning intention and success criteria, we want to be able to apply Pythagoras' theorem to find missing sides. And in today's lesson, we want to firstly recall Pythagoras' theorem and rearrange for missing sides, and then apply Pythagoras' theorem to find the lengths of hypotenuses. So let's get into it. Last lesson, we went through Pythagoras' theorem, and Pythagoras' theorem was a rule that helped us relate the three sides of any right-angled triangle. And so here, if you remember from last lesson, Pythagoras' theorem was written like this: a squared plus b squared is equal to c squared. And what we have here is a right-angled triangle where a and b are the two shorter sides of our right-angled triangle, and c was this special length in our right-angled triangle called the hypotenuse. What we're going to be doing today is actually looking at how we could find the missing, if we have a triangle and we get given the length of A and B, how we can find the length of C, the hypotenuse. So the way that we do this is we're going to use this rule here and rearrange it using a bit of algebra to help us find what C is equal to. So what I'm going to do is I'm going to just rewrite this equation. This is this particular rule, but I'm just going to swap the two sides of my equation. So here, I'm going to write c squared is equal to a squared plus b squared. So here, all I've done is just swapped the two sides. C squared is equal to a squared plus b squared. And then once I've done that, I want to actually just get c by itself. I don't want to have c squared, I just want to have c by itself. And the way that we do this is the way we get rid of square signs is we take the square root. And so here, if I want to find just c by itself, all I need to do is just take the square root of the whole second side. So a squared, square root of a squared plus b squared. So here, what we've done is we've rearranged Pythagoras' theorem to help us find the length of C. So here we've rearranged Pythagoras' theorem to help us find the length of C. The way that we do this is we just take the square root of a squared plus b squared. So for the rest of this lesson, we're going to be applying this formula. So let me just go through a few steps if we want to actually find the length of the hypotenuse in a right-angled triangle. So let's have a look here. Finding the length of the hypotenuse. When we are trying to find the length of a hypotenuse using Pythagoras' theorem, there's 4 steps I have identified here, and some of these just follow that formula. Firstly, what we want to do is we want to identify the lengths of the two shorter sides. So we want to find what those two lengths are. Then what we're going to do is just follow this formula. What we need to do is we need to square both of them. So if you have a look, a squared and b squared, I need to square both the side lengths and then add them together and then square root the result. So we're just going to be applying this formula here. I'm just going to copy this just so we can see what we're doing. Copying and putting it down here. We're going to apply this formula to help us find the side length C. So we want to find the hypotenuse, and so we're going to be using this formula to help me do that. So let's have a go at a couple of examples of this. Here, find the length of the hypotenuse for these right-angled triangles. Round the answer for part B to 2 decimal places. So let's have a go at this. Let's have a look at this triangle. So here, if you have a look at this triangle, we've got the two sides. We've got our 3 sides of our right-angled triangle. We've got 6, 8. So those are my 2 shorter sides. And if you have a look at the hypotenuse, the side which is opposite my right angle, we've got C. We don't know what C is. We want to actually solve for it. So what I'm going to do is I'm actually going to write Pythagoras' theorem out first. So I'm going to write c squared is equal to a squared plus b squared. So that was the formula for Pythagoras' theorem. And then what I'm going to do is I'm going to do that rearranging step. So I'm going to just take the square root. So c is equal to the square root of a squared plus b squared. Now that I've done that, I'm just going to identify what the 2 shorter sides are. So the 2 shorter sides are going to be 6 and 8. And all I need to do is just replace a and b with 6 and 8. So here, that just means that c is going to be equal to the square root of 6 squared plus 8 squared. Okay, so I've what I'm going to do now is I'm just going to square my two sides. So I've put in 6 and 8 into my formula. I'm just going to square the two sides now. So we've got 6 squared, and which is 36. So this is going to be equal to square root 36 plus 8 squared, which is 64. So I've squared my two numbers here. I'm going to now, so I've squared my two numbers. So I've identified what they are. They were 6 and 8. And then I'm squared them. And then now what I need to do is just do this addition here. So I'm going to add the two together. So here, 36 plus 64 is actually going to give me 100. So here's square root 100. And that will actually give me, so square root 100 is going to give me 10. So C is going to equal to 10. Now these steps over here that I've done, these are optional steps. So if you have a calculator, you can just put this equation over here, this one over here, straight into your calculator. So if I did that straight into my calculator, I have square root 6 squared plus 8 plus 8 squared, and that'll give me 10. And that's exactly the same thing that I have here. I've just added those two steps just to show some additional working out. So that's how we use Pythagoras Theorem to help me find missing sides. What I need to do is I square my two shorter sides, add them together, and then take the square root. So square the two shorter sides, add them together, and then take the square root. So let's have a look at the next example. Next example, here we've got another missing side C, and we've got the two other sides, 9 and 8. So let's just follow the same steps as above. I'm going to first write Pythagoras' theorem just to practice writing and getting used to writing it. So I've got C squared is equal to A squared plus B squared. And so C is equal to the square root of A squared plus B squared. Now in this case, C is just, A and B are just going to be 9 and 8. And so I'm going to have 9 squared plus, 9 and 7 squared. Okay. Now I can chuck this straight into my calculator. I can go square root 9 squared plus 7 squared. So I'm squaring my two numbers and then adding them together and then taking the square root. So here I get 11.40. I want that to two decimal places, so that's just 11.40. So here I'm going to have 11.40. So that's how we can find missing hypotenuses using Pythagoras' theorem. What we want to do is we want to identify the two shorter sides of our right angle triangle. In this case, it was for the two cases here, I've circled them in the red and the green just to help me see them. Then what we do is we apply Pythagoras' theorem. We square those two sides, add them together, and then take the square root. And if you've got a calculator, it's quite easy to do that, just putting it straight into your calculator. But regardless, I still want you guys to actually write down those steps here that I have on this. For example, the second one, that's bare minimum in order to actually show that working out. Okay, we can actually apply Pythagoras' theorem to help us solve a few worded problems as well. So let's have a look at this following example. A rectangular wall is to be strengthened by a diagonal brace. The wall is 6 meters wide and 3 meters high. Find the length of the brace required to correct to the nearest centimeter. Now, if you have a look at this diagram, even though they don't tell us that we need to use Pythagoras' theorem or has anything to do with right angle triangles, you can hopefully see that there is a right angle triangle. If you have a look here, we've got this shorter side 6, we've got this shorter side 3, and we've also got this hypotenuse over here, and there's a right angle on the bottom right. And so here, we're going to need to use Pythagoras' theorem to help me find the length of that brace. And so here, I'm actually just going to draw out that triangle again, just on the side here, just so I can see what I'm dealing with. I've got 3 meters, 6 meters, and I want to find the brace. So I'm going to call this guy X this time, because I don't know what that length of the brace is. Okay, so like we normally do, when we need to use Pythagoras' theorem to find that missing side. Once again, it's a hypotenuse. It's a side that's opposite the right angle. And so here, I'm going to write, okay, C squared is equal to A squared plus B squared. And so C is equal to the square root of A squared plus B squared. Okay, now in this scenario, what we need to do is we need to substitute and replace all of these letters with the relevant letters. So first of all, we can deal with A and B. So here, the shorter two sides are 3 meters and 8 meters. So I can write that this is equal to the square root of 3 squared plus 6 squared. Okay, Now on the other side, we aren't solving for c anymore. Actually, we're solving for this missing side, x. So I'm just going to replace c with x because that's what the question actually, that's how I've actually set it up to be. Okay, so now that I've done that, I can just chuck this straight into my calculator. I'm going to go square root of 3 squared plus 6 squared. Ooh. Let me try that again. Plus 6 squared, and that will give me 6.708. And we want to round this to the nearest centimeter, and because this is meters, this is going to become, let me just write this down, 6.708 meters, which is just 671 centimeters. So that's how we can solve these questions when we're trying to find missing side lengths using Pythagoras' theorem. Okay. Quick summary of what we looked at today. In today's lesson, we looked at using Pythagoras' theorem to help us find missing side lengths. In particular, we're looking at how we can use Pythagoras' theorem to find the hypotenuse. And the way that we do this is we rearrange the formula to make c the subject. And so here we had to just take the square root to help us find that. And so what we needed to do was we need to identify the lengths of the shorter two sides, square them, identify the lengths, square those lengths, add them together, and then take the square root. And so here, that's what we did with these following examples here. We were able to put this straight into a calculator to actually make it quite easy for us to solve this, and that is basically what we need to worry about for these questions. So that's it for today, Year 8. If you have any questions, feel free to send me an email or leave me a message on Google Classroom. I'm more than happy to try and help you. But until next time, Year 8, I hope you guys are staying safe wherever you're at, and I'll see you in the next video. Bye!